To understand why professional builders are adopting the Quonset platform, we must first examine the single greatest operational bottleneck in modern construction, the skilled labor shortage. Across the country, the average age of master framers and specialized carpenters is steadily climbing, and the pipeline of new tradespeople entering the workforce simply cannot keep pace with housing demand. When a builder relies on traditional post and beam or stick frame carpentry, their job site timeline is entirely at the mercy of crew availability and individual craftsmanship. The Quonset Hut completely rewrites this labor equation. It transforms the most labor-intensive phase of residential construction, structural framing and roof sheathing, into a precision, standardized assembly process. When a Quonset kit arrives on the job site, it does not consist of raw, unpredictable lumber that must be measured, graded, and cut by hand. Instead, it arrives as a series of heavy-gauge, commercial-grade galvanized steel panels that have been precision-stamped, pre-drilled, and mathematically engineered at the factory. For a general contractor, this represents a monumental operational shift. The entire structural envelope, both walls and roof, operates like a giant industrial-grade Erector set. You do not need a crew of elite, highly paid framing specialists to erect a Quonset shell. A standard general labor crew, equipped with impact wrenches, simple scaffolding, and basic alignment rigging, can assemble and bolt together an entire 1,500 square foot structural envelope in a matter of days rather than weeks. This dramatic reduction in specialized on-site labor not only drastically cuts payroll costs, but it gives builders absolute control over their framing schedules, completely eliminating the costly delays caused by waiting for framing subcontractors to become available. In the professional building industry, predictability is profit. One of the most traumatic lessons contractors learned over the past few years was the extreme vulnerability of the traditional building materials supply chain. When lumber prices experience massive sudden spikes, a builder who signed a fixed-price contract with a client months earlier can see their entire profit margin wiped out overnight before the first shovel even hits the dirt. Switching to pre-engineered steel Quonset kits provides builders with an invaluable financial shield, supply chain resilience, and price stability. Unlike raw dimensional lumber, which is subject to regional weather events, milling shortages, and commodity market speculation, commercial galvanized steel is a highly standardized, globally scaled manufacturing product. When a builder orders a Quonset shell, the cost of the primary structural envelope is locked in with mathematical precision at the factory level. Furthermore, consider the reality of job site waste and theft. On our traditional custom home build, anywhere from 10 to 15% of the purchased framing lumber ends up in a job site dumpster as cutoffs, warped boards, or damaged scrap, an absolute waste of capital. Additionally, piles of expensive lumber sitting on an open lot are a prime target for job site theft and weather degradation. A Quonset kit arrives flat-packed on dense, heavy pallets. There are no warped studs, no split headers, and literally zero structural cutoff waste. Every single square foot of steel delivered to the site is bolted directly into the building. For a builder analyzing cost per square foot metrics, this absolute material efficiency represents an immediate, measurable boost to their bottom line. Let's talk about the cold, hard mathematics of development finance. When a builder or developer purchases a parcel of land and takes out a construction loan, the clock immediately starts ticking. Every single day that a job site sits idle or drags on due to framing delays, the builder is bleeding capital through interest payments, property taxes, insurance premiums, and equipment rental fees, collectively known as carrying costs or holding costs. The secret weapon that Quonset Hut designs offer professional builders is unprecedented timeline compression, specifically the speed at which the building can be dried in. In construction terminology, dried in refers to the point in a project where the building envelope is sufficiently sealed against wind and precipitation, allowing interior mechanical, electrical, plumbing, and finishing trades to begin their work without risking weather damage. In traditional custom home building, reaching dried in can take months of foundation work, complex wall framing, truss crane deployment, roof sheathing, and underlayment installation. With a Quonset hut, because the arched steel panels function simultaneously as the exterior siding, the load-bearing framing, and the waterproof roofing membrane, the structure reaches total dried in the moment the last arch is bolted down and anchored to the slab. We are talking about dried-in a residential structure in weeks instead of months. This allows builders to schedule their interior subcontractors significantly earlier, compressing the overall construction schedule by 30 to 50%. Faster completions mean construction loans are paid off earlier, carrying costs are slashed, and builders can scale their annual volume by turning over projects at nearly double the speed of traditional stick-built contractors. From an architectural and spatial planning perspective, traditional residential construction is heavily constrained by gravity. When designing a custom home using stick framing, architects must constantly calculate load paths. Interior floor plans are dictated by the placement of internal load-bearing walls, structural support columns, and heavy engineered LVL beams required to hold up the roof and second-story floor joists. Changing a floor plan mid-build or customizing a layout for a demanding client often requires expensive structural re-engineering. Professional builders and architects are switching to Quonset designs because the self-supporting steel arch completely liberates them from these structural constraints. The geometry of the arch transfers 100% of the dead and live roof loads directly outward and downward to the exterior foundation perimeter. This means that when a builder erects a Quonset shell, they are creating a monumental, completely column-free interior envelope. This structural autonomy provides builders with an immense competitive advantage when marketing to custom home buyers. Because there are literally zero internal load-bearing partition walls required anywhere within the building, the interior layout is infinitely customizable. A builder can use the exact same exterior shell kit to build a wide-open, industrial-chic luxury bachelor loft for one client, and then turn around and partition that exact same shell into a 4-bedroom, multi-level family residence for another client. If a buyer decides during the framing stage that they want to move the master bedroom wall 2 feet to the left or open up the kitchen into the dining area, the builder can accommodate the change instantly with zero structural risk and zero engineering delays. It is pure, unadulterated spatial freedom. Let's examine the growing legal and financial liability that professional builders face regarding structural engineering in severe weather compliance. Building codes across North America are becoming increasingly stringent as climate change accelerates the frequency and intensity of extreme weather events. In coastal regions subject to hurricanes, Midwestern states plagued by tornadoes, mountainous zones dealing with crushing snow loads, and Western states facing seismic activity and wildfires, getting a traditional timber home engineered to meet modern code is becoming prohibitively expensive. Builders are actively adopting Quonset hut designs because these structures are inherently engineered to conquer extreme environmental loads without requiring complex, custom structural modifications. Let's look at the aerodynamics of the arch. Traditional homes feature vertical walls that meet pitched roofs at rigid right angles, creating wide overhanging eaves. In high wind events, these eaves act like parachute sails, trapping wind and creating massive aerodynamic uplift forces that rip roofs off buildings. A Quonset arch possesses zero eaves in an aerodynamic continuous curve. Extreme winds simply glide over the exterior shell, exerting minimal lateral pressure and zero uplift. Furthermore, consider snow loads and seismic resilience. In heavy snowbelts, traditional flat or low-pitch timber roofs require massive, expensive truss engineering to prevent structural collapse under thousands of pounds of wet snow. The steep upper curvature of a Quonset arch naturally sheds heavy snow accumulation, while its structural steel composition easily supports extraordinary static loads. In seismic zones, the bolted, multi-panel steel arch possesses high tensile ductility, the physical ability to flex, deform slightly under kinetic stress, and return to its original shape without fracturing. For a professional builder, ordering a Quonset kit that arrives from the factory with pre-stamped, state-certified engineering documentation guaranteeing compliance with 170-mile-per-hour winds and high seismic zones completely eliminates engineering headaches and drastically accelerates the municipal permitting process. For years, the primary skepticism surrounding residential metal buildings was rooted in building science, specifically the challenges of thermal bridging and condensation. Steel is an exceptional conductor of heat. If a builder attempts to insulate a metal arch using traditional fiberglass bats or standard residential techniques, the indoor temperatures will swing wildly, and the point where warm, humid indoor air meets the cold steel shell will trigger massive condensation, causing it to literally rain inside the walls, breeding toxic mold and rotting interior finishes. Professional builders have completely mastered this technical hurdle, turning what was once a liability into one of the most high-performing thermal envelopes in residential architecture. The definitive, non-negotiable solution adopted by the industry is the application of closed-cell polyurethane spray foam insulation. When applied directly to the interior surface of the raw steel arch, closed-cell foam expands to fill every single corrugation, bolt head, and microscopic seam. This application achieves three vital building science objectives simultaneously. First, it forms a permanent monolithic thermal barrier with an extraordinary R value per inch, completely eliminating thermal bridging. Second, because closed-cell foam is impermeable to water vapor, it acts as an absolute vapor barrier, permanently preventing interior moisture from ever reaching the cold steel shell, stopping condensation dead in its tracks. Third, the high-density foam physically bonds to the steel panels, adding immense structural rigidity and acoustic dampening to the entire envelope. Once the foam cures, builders install a secondary, decoupled interior framing system, such as curved timber ribs or light-gauge steel tracks to hang drywall or wood paneling. The result is an airtight, ultra-quiet, hyper-efficient residential envelope that routinely outperforms traditional 2x6 timber framing in energy efficiency blower door tests. Let's address the bureaucratic realities of the construction business: zoning approvals, building permits, and bank appraisals. In the early days of alternative housing, owner-builders attempting to put up Quonset huts often faced severe resistance from conservative municipal zoning boards and lending institutions, who viewed the structures merely as agricultural barns or industrial storage sheds. Professional builders have systematically dismantled these institutional barriers by professionalizing the presentation and execution of Quonset residences. When a seasoned builder submits a local building department today, they are not submitting a rough, hand-drawn sketch. They are delivering a comprehensive, highly detailed set of architectural blueprints accompanied by state-certified structural engineering stamps provided directly by the steel manufacturing facility. Because these engineering packages explicitly demonstrate compliance with all local international residential code, including egress, light, ventilation, wind loads, and energy conservation, building officials are legally bound to approve the permits. Furthermore, the appraisal and mortgage financing landscape has shifted dramatically in favor of professional builds. When builders finish a Quonset home with high-end exterior end walls, luxury interior kitchens, architectural lighting, and permanent reinforced concrete foundations, the completed structure clearly qualifies as a residential single-family dwelling. Professional builders work closely with lenders, utilizing modern appraisal frameworks that classify these homes under unique or high-performance custom residential construction. By establishing verified comps and demonstrating superior durability and energy efficiency, professional builders are routinely securing standard construction to permanent mortgages for their clients, fully normalizing the Quonset platform in the mainstream financial market.